Welcome to the monthly module on respiratory protection. This course has been designed to be taken individually or to be led by a facilitator who will make connections to your local setting. Anyone who takes this course on an individual basis will be required to have a discussion with their supervisor as a condition to complete the course. The learning objectives for this course are: recognize the types of respiratory hazards. Identify the types of respirators and the situations each will be used. Describe the medical signs and symptoms that may limit or prevent the use of a respirator. Identify the difference between a fit test and a seal check, and identify the frequency of each. Identify the proper procedures to clean and store a respirator. In order to complete the course, you will have to achieve a score of 80% or better on a final quiz. Loaded into the glossary section of the course player are some terms that appear throughout the course. Please take a moment to familiarize yourself with those terms. Respiratory hazards can exist in various forms at virtually all of our work sites. These hazards may be gases, vapors, dusts, mists, fumes, smoke, sprays, and fog. Some of these substances, if breathed in, can make you sick or even kill you. Certain respiratory hazards act quickly, like carbon monoxide, which is an invisible odorless gas that can make you unconscious or kill you in minutes. Other respiratory hazards can take years to make you sick. This includes asbestos, which can cause lung cancer years or even decades after you breathe it in. As a result, respiratory protection is needed if personnel must enter any area in which there may be either a deficiency of oxygen or an elevated concentration of toxic chemicals in the air. What are some of the situations you may be exposed to that will require the use of respiratory protection? Common situations that require the use of a respirator include spills, remediation activities, sampling, repair or maintenance, confined space entries, and maintenance activities that generate aerosols, vapors, or consume oxygen. When respirators are required, the employer must have a respiratory protection program. This program must meet the requirements of either the federal, state, or provincial respiratory protection standard. The standard requires the employer to do the following: evaluate the respiratory hazards in the workplace, provide medical evaluations and respirator fit testing, provide respirators as well as provide for the maintenance, storage, and cleaning of respirators, provide worker training about respiratory hazards and proper respirator use, and conduct a periodic program review. Respiratory protection must be selected based on the hazards you will be exposed to. Not every respirator will protect you against every hazard, so it's important to select the right one. Failure to select the correct equipment may result in injury or death. For example, filtering facepiece respirators may protect you against particulate hazards like dusts. However, a filtering facepiece respirator will not protect you against gas and vapor hazards, such as solvent vapors. If you are exposed to airborne hazards that are not particulates, you will need a different type of respirator. Click each tab at the top of the screen for a description of the 3 respiratory hazards. Oxygen deficiency can occur when air is displaced by gases and vapors heavier than air, or when the oxygen is removed by an oxidizing process, such as aerobic action, combustion, or rusting. Without an adequate concentration of oxygen in the air, the worker is in an immediately dangerous to life and health atmosphere. Normal breathing air is 20.9% oxygen, and the Clean Harbors policy requires respiratory protection in atmospheres below 19.5% oxygen. Permit spaces such as boilers, vaults, and sewers are examples of possible oxygen-deficient work areas. Oxygen-deficient atmospheres may cause a person to feel lethargic and potentially lose consciousness. Aerosols are fine particles, solid or liquid, that are suspended in air. Aerosols can be classified in 2 ways. First is by their physical form and origin, and the other is by their physiologic effect on the body. Particulate contaminants are associated with lung disease such as asbestosis, silicosis, pulmonary fibrosis, and allergies. Gases and vapors may cause irritation, asphyxiation, systemic poisoning, or other toxic effects. The basic purpose of any respirator is to protect the respiratory system from inhalation hazards. Respirators provide protection in one of two ways. The first is by removing contaminants before the air is inhaled. This type of respirator is called an air purifying respirators, or APR. The second is by supplying an independent source of breathing air. This is called an atmosphere supplying respirators, or ASR. Click the buttons below for a description of each type. You will be able to proceed to the next slide after viewing each description. An air purifying respirator uses an air purifying filter, cartridge, or canister to remove specific air contaminants by passing ambient air through the air purifying element. These respirators include half mask, full face, and powered APR, which uses a blower to pass contaminated air through a HEPA filter. It is important to stress that APRs do not supply oxygen, and instead use filters or chemical cartridges to filter contaminants. There are two types of air purifying respirators, a negative pressure respirator and the positive pressure respirator. In a negative pressure respirator, mechanical filters or a chemical medium is used, while a positive pressure respirator uses a fan to force incoming air through filters in the user's mask. What type of situations warrant the use of an APR? The following criteria indicates when an APR must be worn. The Clean Harbors standard requires the oxygen level to be between 19.5 and 22%. APRs must use the proper cartridge for the chemical that will be handled. These cartridges will not exceed the maximum use concentration or defined action levels. MUC and action levels will be discussed in more detail later. Last, APRs can never be used in IDLH situations. As always, consult your health and safety manager with additional questions. Now, identify if there are any chemicals that would result in the inability to use an APR. This is a partial list of chemicals that do not have sufficient warning properties, or are chemicals that cartridges are inefficient at removing. Always ensure your cartridges are effective against your contaminant. What are some signs an APR cartridge is used up? If you ever smell or taste the contaminant, the cartridge may be used up. This is also called a breakthrough. Additional warning signs are a clogged cartridge, irritation, or the end of service indicator. If this happens, leave the area and check for proper face seal, damaged or missing respirator parts, and saturated or inappropriate cartridge or canister. An important part of the respiratory protection program includes identifying the useful life of canisters and filters. Each filter and canister shall be equipped with an end-of-service life indicator, or ESLI. If there is no ESLI, a change-out schedule for canisters and cartridges will be created. This will be discussed on the next slide. If you have an APR with you, please identify the ESLI indicator. If there is no ESLI appropriate for conditions, a change-out schedule for canisters and cartridges will be created. This schedule will be based on objective information and data to ensure canisters and cartridges are changed before the end of their service life. As a rule of thumb, a pair of cartridges should last one 8-hour shift, but things may vary for extreme environments. As always, if you are unsure about your cartridge change-out schedule, consult with your health and safety manager. What are factors that would affect service life? Change-out schedules will be established before work begins, and the following factors must be considered. First is the concentration of contaminants in the air. The patterns of respirator use. For instance, will the respirator be worn intermittently or continuously? The work that is being performed and how it impacts the personnel's breathing rate. And environmental factors like temperature and humidity. A HEPA filter is a type of mechanical air filter. It works by forcing air through a fine mesh that traps harmful particles such as dusts, mists, fumes, as well as things like pollen, pet dander, dust mites, and tobacco smoke. At Clean Harbors, when regulatory agencies or other standards call for particulate or HEPA filters, we use the Magenta P100 filters because it offers the highest efficiency and the greatest range of aerosol protection. As always, if you have a question about selecting the appropriate equipment for a task, contact your health and safety manager. A positive and negative pressure check must be done each time an employee puts on a respirator. These tests ensure you have a good seal around the mask, and it will protect you from whatever chemical hazard you're about to face. Follow the manufacturer's recommended process for the tests. Click the video for a demonstration of a positive and negative seal check.
Chapter 2. User Seal Checks. Always check the seal of the respirator according to the procedures demonstrated for your specific respirator configuration. There are two methods to check your seal: positive pressure and negative pressure. The positive pressure seal check is the primary method for verification of a good seal for all cartridge and filter configurations, and is also the only method for this respirator with the 2000 series filters. To conduct a positive pressure user seal check, first, remove the exhalation valve cover by depressing the bottom of the cover with your thumb, and then sliding the cover up parallel with the lens. Next, place the palm of your hand over the exhalation valve and exhale gently. You want to ensure a good seal of the exhalation valve, so, in order to do this, cover the entire face of the blue valve with the base of your palm. If the facepiece bulges and no air leaks are detected between your face and the facepiece, a proper seal has been obtained. If face seal air leakage is detected, however, try repositioning the respirator or readjusting the tension of the straps. Now that the seal is secure, we must return the exhalation valve cover. You can do this either by reversing the removal process you just completed, or simply hold the exhalation valve cover on the sides even with the notches on the two tabs on the inside. Then, contact the ridge of the lens on each side of the exhalation valve assembly with your fingers holding the valve cover. Slide downward until the valve cover snaps in place, and you're done. Note that if at any point during replacement the respirator becomes dislodged, you will need to redo the user seal check. To feel more skilled and confident with this procedure, we suggest practicing in front of a mirror. If face seal air leakage is detected, remember to reposition the respirator or readjust the tension straps, and always recheck your seal. Moving on, let's turn now to the negative pressure user seal check, which can be done for additional verification of a good seal for this respirator with the 6000 series cartridges and filters 7093 or 7093C. To perform a negative pressure user seal check with the 6000 series cartridges, place the palms of your hands over the face of the cartridges, combination cartridges, or open area of the 501 filter retainers, and inhale gently. If you feel the facepiece collapse slightly and pull closer to your face with no leaks between your face and the facepiece, a proper seal has been obtained. If face seal air leakage is detected, reposition the respirator or readjust the strap tensions as you did before. Try not to disturb the respirator seal, however, by pressing too hard. Next, we will demonstrate the negative pressure user seal check with the 7093 or 7093C filters. First, squeeze or press the filter covers toward the facepiece and inhale gently. If you feel the facepiece collapse slightly and pull closer to your face with no leaks between your face and the facepiece, a proper seal has been obtained. If face seal air leakage is detected, reposition the respirator on your face or readjust the tension of the straps to eliminate the leakage and recheck the seal. As always, during negative pressure seal checks, be careful not to disturb the respirator seal by pressing too hard. Finally, we will demonstrate the negative pressure user seal check with dual airline. First, Disconnect the airline hose from the air control valve. Next, with the breathing tube still connected to the air control valve, inhale gently. If you feel the facepiece collapse slightly and pull closer to your face with no leaks between the face and the facepiece, then a proper seal has been obtained. For combination dual airline where the cartridges or filters are attached, perform the user seal check as described above under the appropriate cartridge or filter that's being used. Again, if face seal air leakage is detected, reposition the respirator on your face and or readjust the strap tension. Recheck the seal to ensure it's secure. Once that both positive and negative pressure user seal checks have been confirmed, you may enter the contaminated area. Please note, if you can't achieve a proper seal, do not enter the area. Instead, see your supervisor.
Now it's your turn. Using your respirator, conduct a seal check. The other respirator type is an atmosphere supplying respirator, or ASR. This model includes supplied airline respirators and self-contained breathing apparatus, also known as SCBA. Supplied airline respirators, or SARs, are usually part of a multi-cylinder cascade system. Each cylinder lasts 3 to 5 hours per person, and lines are limited to 300 feet or 90 meters. These systems will always use an auxiliary SCBA, or escape or egress bottle. The benefit for this equipment is its lightweight design and duration of use. The downside is this line may tangle, so it requires the user to practice proper hose management. SCBAs can, depending on the user and the work, be a low-pressure cylinder that may last 20 minutes or a high-pressure cylinder that lasts up to 40 minutes. These respirators are bulky, but allow for more independence than a SAR. ASRs must use an air supply that meets or exceeds the air purity standards that appear on the screen. An example of this is Grade D air. A certificate from the supplier must be on file for any bottle of breathing air that is being used. It is important to keep all PPE, including respirators, clean and in good working order. Click the video on the slide for a demonstration of how to clean a respirator.
Chapter 5. Cleaning and Storage. Cleaning your respirator is recommended after each use, though it's important not to use solvents when cleaning as they may degrade some components and reduce effectiveness. In order to clean your apparatus properly, first, remove the cartridges, filters, and/or breathing tubes and nose cup. If needed, the exhalation valve cover, exhalation valve assembly, speaking diaphragm, bayonet assembly, lens, and face seal can also be removed. After removing filters and cartridges, clean the facepiece by immersing it in a warm cleaning solution, the temperature of which should not exceed 120 degrees Fahrenheit or 49 degrees Celsius. Scrub with a soft brush until the facepiece is clean. You may add a neutral detergent, but do not use cleaners containing lanolin or other oils. Disinfect the facepiece by soaking it in a solution of quaternary ammonia disinfectant or sodium hypochlorite, 1 ounce, 30 milliliters household bleach in 2 gallons, 7.5 liters of water, or other disinfectant. Next, you'll rinse the facepiece in fresh warm water, then air dry it in a non-contaminated atmosphere. Do not replace the nose cup until the facepiece is completely dry. Respirator components can be inspected during cleaning and must be inspected prior to each use. A respirator with any damaged or deteriorated components should be repaired or discarded. The cleaned respirator should be stored away from contaminated areas when not in use, per your employer's instructions.
How often should a respirator be inspected? Take a moment to discuss or think about it, and then click the button on the slide. According to the Clean Harbors Standard, you must inspect respirators before each use, during cleaning, and after fit testing. SCBAs require additional inspection and testing. A documented inspection for each SCBA must be completed at least monthly. SCBA manufacturers and the NFPA recommend at least an annual flow test. Hydrostatic testing is the most common way to check an SCBA cylinder for leaks or flaws. During a hydrostatic test, the cylinder is examined to ensure it can safely hold its rated pressure. Hydrostatic testing is crucial since these containers can explode if they fail to contain compressed gas. All SCBA cylinders require periodic hydrostatic testing, as required by national, state, or provincial authorities or per the manufacturer guidelines. If a problem is identified during an inspection, it needs to be corrected before the respirator is used. Click the button on the slide for SCBA cylinder tank inspection guidelines. Shown here are the cylinder inspection guidelines. After reviewing these guidelines, advance to the next slide for a short video on how to inspect your respirator.
Chapter 4. Inspection Procedure. Your respirator must be inspected before each use as well as during cleaning, in order to ensure that it's in good operating condition. Any damaged or defective parts must be replaced before use. Do not enter a contaminated area if parts are damaged or defective. To properly inspect the respirator, the following 9 procedures are recommended. 1. Check the facepiece for cracks, tears, and dirt. 2. Make sure the facepiece, especially the face seal area, is not distorted. 3. Examine inhalation valves for signs of distortion, cracking, or tearing. 4. Make sure that the head straps are intact and properly elastic. 5. Examine all plastic parts for signs of cracking or fatiguing. 6. Ensure the bayonet gaskets are in good condition. 7. Remove the exhalation valve cover, examining the exhalation valve and valve seat for signs of distress. 8. Examine the speaking diaphragm for any more signs. 9. Replace the exhalation valve cover and inspect the lens for any damage that may impair the respirator performance or vision. Once inspection is completed, you may put the respirator on.
Now it's your turn to inspect your respirator. Take a few minutes to apply the steps in the prior slide's video. So how do you know which type of respirator should be used for each situation? The first thing to identify regarding the selection of a respirator is the assigned protection factors, or APFs. The APF is the measure of a respirator's overall effectiveness in conjunction with a good respirator program. Many groups and respirator manufacturers have developed lists of APFs. Some guidance for each type of respirator is listed on the slide. Another value important to the classification of a respirator is the maximum use concentration, or MUC. The MUC is established by multiplying the assigned protection factor by the lowest of the PEL, TLV, or OEL. This value, which again is the MUC, identifies the largest concentration at which a respirator may be used. To choose the proper respiratory protection, you must be familiar with action levels and how they are used. This slide will walk through the process of determining if, based on prior identification of expected conditions, level D, level C, level B, or level A protection is appropriate. Action level D requires no respirator protection. This maximum action level is determined by taking the halfway point of the PEL, TLV, or OEL. You should use the lowest of these 3 values. PELs and TLVs are located on SDSs, as well as on OSHA tables Z1 through Z3. OELs are located on the Canadian Provincial Ministry website or on an SDS. If the materials you are working with exceed the established Level D maximum, you need to proceed to Level C. Level C requires the use of an APR. There are 3 values that determine if Level C protection is appropriate. The first is 10 times the Level D maximum. The second way is half of the IDLH, or immediately dangerous to life and health value. IDLH values can be found in the previously mentioned OSHA tables, on the Canadian Ministry websites, or in the ACGIH TLV booklet. If you have a question about this value, you should reach out to your health and safety manager. The third way to identify if Level C is appropriate is as long as the materials you expect to encounter do not exceed the APR's cartridge's MUC. If any of these values are exceeded, then Level B protection is required. Level B protection requires the use of an ASR because of the expectation the materials will be 1,000 times the Level D maximum, or that the situation will be deemed an IDLH, in which case health and safety approval is required. Anything greater than this would be Level A, and this also requires health and safety approval. The respirator standard, as well as the resources section of this course, includes an action level calculation worksheet. In addition, it is worth noting, along with identifying the action level, personnel will also have to perform air monitoring for the expected chemicals. Now, take a moment to review the action level calculation worksheet and then advance to the next tab for an exercise. Now, using the materials in the resources section or the materials distributed by the instructor, complete the questions on the handout. The last topic that will be discussed is how respirators are connected to the company's medical surveillance program. Specifically, before someone is provided a respirator, there are a few things that need to take place. Use the buttons at the bottom to identify why a medical screen is necessary, identify what the medical screen consists of, and learn why a fit test is necessary. An employee cannot wear a respirator unless they have been medically cleared to do so. This is required because respirators put additional resistance on the respiratory system. Workers with an undiagnosed respiratory or cardiovascular problem could trigger a serious medical problem by using a respirator. Putting all workers through the medical surveillance program will ensure they are healthy enough to perform the potential work. The company's health and safety department manages the medical evaluation of each employee required to wear respiratory protection. Evaluations are done prior to the employee starting work and will be repeated based on the recommendations of the physician. A medical evaluation is also performed if an employee suffers from signs of exposure. A fit test reveals another evaluation is necessary. Changes in workplace conditions provide the opportunity for physiological stress, and any time it is deemed necessary by the health and safety or the program administrator. Spirometry is a common type of pulmonary function test that measures how well a person can move air in and out of their lungs. In occupational settings, spirometry can be used to establish a baseline before assigning a worker to job tasks that are physically demanding, that require the use of a respirator, or may expose the worker to respiratory hazards. This test is also used to track lung function over time and to evaluate workers who experience signs or symptoms of respiratory disease. Fit tests are required before an employee can use a respirator. The employee will be fit tested with the same make, model, style, and size of respirator that will be used. There are 2 types of fit tests. The first is a quantitative test, and it is done with a machine and measures the actual fit of the respirator. The other method is a qualitative fit test, and it relies on the user's sense to a chemical that will identify if there is any leak in the seal of the respirator to his or her face. There are several factors that affect a respirator's fit. Prescription safety glasses may be worn with a half-face respirator. For full-face respirators, special inserts must be worn, and these inserts will be provided as part of our basic PPE policies. It is worth mentioning that contact lenses pose a special hazard when working around toxic substances and are not permitted when respirators are in use. Over time, a person's facial structure may change. In the event of changes to one's facial structure, for example due to facial scarring, dental or cosmetic surgery, a new fit test is required. Head protection may only be worn over the respirator straps and not between the respirator and the head. The last factor that may affect a respirator's fit is the presence of facial hair. There should be no obstruction between the wearer's skin and the mask. Click the images on the screen for examples of acceptable and unacceptable types of facial hair. The course is now complete. At this point, you should be able to recognize the types of respiratory hazards, identify the types of respirators and the situations each will be used, describe the medical signs and symptoms that may limit or prevent the use of a respirator, identify the difference between a fit test and a seal check, and identify the frequency of each, identify the proper procedures to clean and store a respirator. In order to complete the course, you will have to achieve a score of 80% or better on a final quiz.